So RSTP, it is also an open standard, right? It is standardized by IEEE with standard of 802.1W, open standard. Remember, CST, RSTP are open standard, right? PVST, RPVST are Cisco. Okay, this is Cisco footprint. So actually, this is the enhancement to the legacy 802.1D STP. Okay, why they came up with RSTP is when STP was introduced, when this protocol was introduced, at that time STP was faster. That is, in order to bring one port up taking 30 seconds, it was faster at that time. But today's technology has evolved. Now everyone has become very fast, right? So the IEEE has thought that the STP must also become faster. So they came up with the RSTP. Everything is same. Everything is same. Rule breach, everything, elections, everything is same. The only thing is this will be more faster, right? In our STP, the convergence time will be around 30 to 32 seconds, right? But here within seconds, within 1 to 2 seconds, the topology will be converged. It is faster. It is not 30. It will be very faster. Okay. So designed to speed up convergence, right? To speed up the convergence. That is, if the link is down, in order to make the redundant link up, that is called convergence, and the convergence time will be faster. Link type is derived from duplex mode. Actually, you know, RSTP, it works on links according to the links. If the link is full duplex, if the link is full duplex, the full link is full duplex, it will be working as RSTP. If the link is half duplex, it will work as CST, the legacy CST. So it is dependent on the duplex mode. If it is full duplex, the switch will think that it is point-to-point collection. Yeah, it is. It uses RSTP. It will think that point-to-point connection, point-to-point connection. That it will think that only one bridge is connected to me. If it is full duplex, if it is half duplex, it will think that a hub is connected in between. A hub is connected in between, and immediately it will switch to CST. And the port roles, yeah. Which one? RSTP. Rapid spanning tree protocol. Rapid. So the port roles will be same again. That is, acha. Here the change is we used to have block port, right? We used to have block port. If the port is neither getting the role of root port nor designated port, it will be going as block port in common spanning tree. But here we'll be having alternate port, right? For supposing that my switch one, there are two ports. There are two ports. Okay, this can become the root port and this can become the root port. Okay, we'll do elections. We'll do elections and we'll declare one as root port, right? Other one maybe it will become the designated port or block port, right? But here, what will happen is it will become the root port in RSTP. The second port will become alternate port. Alternate port means it is the redundant port for the root port. If the root port goes down, immediately this port will come. That is the alternate port. And we have backup port. Backup port. Backup port is designated port. Okay. These two ports underwent election and this became the designated port. Right? In CST we used to make this as block port in common spinal tree, but in RSTP we'll make it as backup port. We'll say it as backup. That's it. In CST we have only one name, that is block port, but here we are having different name, that is alternate port for the root port and backup port for the designated port. That's it. Yeah, again the configuration is uh, switch, go to switch configuration mode. So configuring and verifying RSTP, go to configuration mode of the switch and tell show span tree mode rapid PVST. Span tree mode rapid PVST. It will switch to RSTP. Okay. And if you want to check whether it has switched or not, type show span tree summary. This is to configure, this command is to verify. Right? Yeah. So this is just simple topology. I'll just show you by switch 1 and switch 2. Okay. Show span tree summary. Show span tree summary. Switch is in rapid PVST mode. Switch is in rapid PVST mode. I told you, if you show span tree mode, if this command is given, output is shown, where you can see in which mode the span tree is running, right? And these are some details. These are some features that is not our cup of tea. And for which VLAN the span tree is running? For VLAN 1. Okay, one VLAN. It will show whether any port is block port, whether any port is in the blocking state 0, any port in listening state 0, any port in learning state 0, forwarding state 0, STP active, this is the number of ports that are active are 2. Okay. Now actually we checked it in on this switch. Okay, on this switch 2 ports, Ethernet 0 by 0, Ethernet 0 by 1, both are active. Okay, and this is the root bridge and both are in forwarding state, right? And on this switch we'll check now. On switch 2, we'll check now. Show spanning tree summary. Yeah, can you see this? Same thing, RPVST mode, rapid PVST. It is also running for the VLAN 1, but blocking port is 1. We have one blocking port, and the both are STP active. In the sense, they both will part both are part of STP. Okay. Now let us see which port is blocked. Show spanning tree VLAN 1. Okay. Or else I will give show spanning tree. Right. I have only one VLAN, so it is showing one VLAN. Okay. Now, now see. Show spanning tree. Can you see? VLAN 1. This is for VLAN 1 spanning tree. This is for VLAN 2. This is for VLAN 3, and this is for VLAN 4. Okay. This is the output of show spanning tree. Okay. Now I'll give specific VLAN. I'll give specific VLAN, that is show spanning tree VLAN 1. Only for VLAN 1 will be shown. VLAN 2. Only for VLAN 2 will be shown. VLAN 3. Only for VLAN 3 will be shown. Okay. For all these VLANs, check here. This is my priority. This is the priority of root. Base MAC address of root. This bridge is the root. That is switch 1 is the root of the VLAN 3. If you are typing show spanning tree VLAN 3 will or show spanning tree, you will come to know these details. What is the priority, what is the base MAC address, and who is the root bridge. And you'll also come to know what are the timers. 2 seconds, max time is 20 seconds, and forwarding delay is 15 seconds. Right? Remember, this will be the details of root bridge, and this will be the details of self, that is this bridge. Okay, and this will be the details about what is the role of the bridge, what is the role of the port. Okay, what is the role of the port and what is the status, whether it is forwarding or whether it is in the link state, whether it is in the listening state or learning state or blocking state. This will be shown here, and what will be the cost of mine to reach the root bridge. And this will be my prior port ID. See, I have shown you port ID. This is the port ID. Priority plus port number. That is 128 is by default priority plus 1. Right? See. Root bridge ID, root bridge details. Okay, if you are seeing it on switch 1, it is written this bridge is a root. It means the switch 1 is a root bridge. If you see switch 2, You don't have that line. Okay. So again the same thing, 2 seconds max is. And can you see here, Ethernet 0 by 0 is a root port and Ethernet 0 by 1 is a alternate port. Alternate port in the sense, it is an alternate port for the root port. If the root port goes down, this port will come up. Alternate port. Okay. And see the status is, it is in forwarding state and it is in the blocking state. Right? And the cost will be 100 and this is my port ID and what is the link time. That's it. And now I'll show you. Show spanning tree blocked ports. Four VLANs, same port is blocked. Ethernet 0 by 1, Ethernet 0 by 1, Ethernet 0 by 1, Ethernet 0 by 1. So number of blocked ports segments is 4. That is, for 4 VLANs, that is why the value is 4. But actually the port is only 1. Only one interface is blocked, but 4 instances, so it is showing the value as 4.